All right, so let's look at our Venn diagrams. I have a spinner, 1 through 8. I want to fill in the Venn diagram for evens, primes, and then anybody remember from your Venn diagram days what goes in the middle here? The intersection, both of them, all right? I could put either it in evens or I could put it on primes. And what happens if it doesn't even fit in any of the circles? Goes outside somewhere here, okay? Goes outside somewhere here, okay? So the first one we have is the number 1. I will let you know, and I know this is always a tough one to remember, 2 is the first prime number you encounter. 2 is the first prime number. So 1 is not prime, and is it even? No, so it doesn't fall in either my circle. Where should it go? Somewhere outside. All right, you guys can take it from here. Where should 2 go? Remember I said 2 is the first prime number you encounter. It's even and it's prime, so it should go in my intersection. 3. Where's 3 going to go? Should go in my primes, yep. Here we go, 4. Even. 5. Prime. 6. Even. 7. Prime. And 8. There we go, under my evens. All right, let's talk about 2 different things. Union, take a look here. That's an or. It's in A or it's in B, but not both. And the symbol for that is the little U. And then we also have intersection, which is it's in A and B, and that's the upside down U. I'm going to start using this symbol a lot at the end of class today. All right, the intersection, it happens in A and B. So help me fill out a couple questions here. Give me everything from A or B from that previous Venn diagram. All right, so again, let's get used to writing the notation A union B. Everything in A and everything in B, but not in both. All right, so look at your Venn diagram right now. What numbers should I be putting in this set? A union B. In A or in B, but I can't have both. Here we go. Let's roll. 7. What do you got for me? Yep. 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 Any more? Thank you. Thank you for putting them in order as well. Everything in A or in B. What about the intersection of them now? A intersection B. It's in both. It's in both. What do you got for me? 22. What do you have? Now it starts getting interesting. $22. Okay. We'll have a duplicate number in a minute. 12. 2. 2 is the only one that was in both. Okay. Questions? Using the Venn diagram, A or B, or the intersection A and B. We all right? Okay, let's move it on. Here's where we are today. Conditional probability. Probability that an event B will occur given A already occurred. So an event already occurred. Based on an event already occurring, what's this new probability? Notation. Here you go. Here's the notation you'll see. Probability that B will occur. You're going to see a vertical line now given A has already occurred. And just make a little note. That vertical line is given A has already occurred. Okay? So I'll find the probability B is going to happen given A already occurred. And let's go to a Venn diagram to do this. Okay? All these dots just mean, here you go, A occurred. A and B just occurred. B occurred. Neither A nor B occurred. That's what these dots are in here for. Here's what I want. Consider the probability. What's the probability of A given B occurred? All right, so B has already occurred. Here you go, visual, visual. B has already occurred, guys. So now that B has occurred, what's the probability I'm going to get A from that? Well, let's take a look. I won't call anybody yet. How many in set B, because B's already occurred, contain also A? 4. If you're wondering, 1, 2, 3, 4. Out of, not all the dots now, because what has already occurred? B. So my choices are narrowed to set B now. How many choice outcomes do I have in B? Well, count them up. Count them up. B's already occurred. Count them up. How many do I have in B? Here we go. 19. Okay. I'll wait till those duplicate. 2. 12. Or 1/3. So the probability that A, these 4 here occurred, given B already occurred. So now my choices are only in set B. Everyone all right? All right, let's go to the next. Yes, Sarah, go ahead. Because B has already occurred. So what's the probability I get A given B has already happened? So my choices now are not the entire Venn diagram. It's just coming from B now that it occurred. Okay, so that's where all these dots get reduced to just the ones in B. Okay? Probability now, B occurs given, yep, Jess, sorry. 1. Well, it should just be like this one right here. That means it occurred in A and B. This one right here, it just occurred in A. This one right here occurred in neither, maybe C, I don't know. Okay? All right, let's flip it on you now. Probability B happens given A has already happened. So hey, now focus your attention on A. A has already happened. What's the probability now B will occur out of that? Well, how many of the B's are contained in set A? Still 4. But now, out of what? Now that A has occurred, it's out of 10. And that'll give me 2 out of 5. Questions on where they're coming from here, because that's just a Venn diagram. We'll get to a table now. Okay, now what I want is construct a two-way frequency table for me. And I'll set it up for you. You fill it in. Ready? Here we go. Well, B could happen or not B could happen. And then A could happen, not A could happen. Those are my only choices, right? A, not A, B, not B. And then we always have our totals on the bottom and on the top. So total, oh, sorry, I gotta squeeze it in here. Total. Okay, help me fill it in now. Help me fill it in. You're gonna have to count some dots. Who's starting us off? 13? 13? Okay, here we go, Sarah. First one here. This means B and A both occurred. How many times? B and A both occurred at the same time. No, B and A. So set B and set A. How many are in both? 4. All right, set A and set B. Thank you. Who's up next? Here we go, 17. Oh, see, we got doubles here. Pick who's going to be 17. Well, both of you have 17, so. Does anybody have 18? Okay, ready? Here, see how this works? Progress. Anybody have 19? Sold, 19. Ready, Shan? In B, but not in A. In B, but not in A. 8, yep. So we know a total of B is 12. All right, help me out here. 15. I had a 15 in the house. Just one? Great. Here we go, Ken. Not in B, but in A. 6. Thank you. You want to take not B and not A as well? They're not in either of them. 7. So if we got a total of 13. And now you guys can figure out the totals along the way here. How many are in A? 10. Not in A? 15. Either way you go, total of 25. Okay. All right, help me out. Oh, yep, sure, Olivia. Yes, in a two-way table, absolutely. Yes, yes, yep. Okay, here's our conclusion here. Go back to the first question I asked you, which was the probability of A given B. That's what I asked you first in part A. What did we give for an answer there? What did we give? 6. What did we get for an answer there? Part A. I asked you for the probability of A given B. What did we find the result was? Okay, 4. I'm going to go back to 4 over 12, but yes, 1 over 3. Need your help now. Where's the 4 come from? Look at your table. Where's the 4 come from? Carter? So you're telling me that's A intersection B, right? Both happen. Out of still need your help, guys. Where's the 12 in that diagram? Total of B, right? The number of B. Ready? Part B, what did I ask you for? B given A. What did you guys tell me was the result? What was the answer to that one? Non-reduced. 19? Not reduced. What was the answer to that one? What was it? 4 over 10. Hey, where'd the 4 come from again? Both, right? Intersection, right? Where'd the 10 come from? Look at your table. Where'd the 10 come from? That was how many were in? Oh. I think are we seeing a pattern maybe how to do these? No, not at all. A given B, how many are in? Where'd that 4 come from? How many are in both over how many are in the one that is given, B? B given A, how many are in? Both over what occurred already, A. We'll get there. All right, I'm just trying to show you a little pattern here. Questions are where we are here. What do we got? We all right? Where I'm getting these numbers? 4, here's the number 4. Let me finish today. Just let me finish. This is only a third of what I need to do here. Okay, just let me finish. I know you're excited. Okay, now read it off the table here. Can you guys go back to page 20 of your notes? Go back to page 20 of your notes real quick. You'll see the same exact table, except we filled it in with decimals. Rounded to the nearest thousandth, correct? Okay, what do you guys have for no household smokers and student has asthma? What decimal do you have there? 0.073. We're going to turn it into actual people now, all right, and say it's 73. We're going to multiply everything by 1,000 because this table's out of 1,000 now. All right, so keep going back and forth now. Here you go. What decimal did you have for student has asthma and at least one household member smokes? 0.120. So how many people is that going to be out of 1,000? 120. Yep. So keep going back and forth now. Turn those decimals into actual people by multiplying by 1,000. Everyone, we all match? Okay, gonna need somebody here. Get your calculators ready too. 20, here we go. 20, okay, here we go. Everyone, also, a randomly selected student has asthma. Stop. It's not out of 1,000 anymore. Look at all the students who have asthma. These are the only ones I'm going by right here, are the 193. Not out of 1,000. A randomly selected student has asthma. So now this is going to be out of 193. What's the probability that that student has one household member who smokes? So out of the 193, how many are we looking at? 120. But it is not out of 1,000. Why? Because we know this person has asthma, and there's only 193. Not a randomly selected student, a randomly selected student who has asthma. Go, find the decimal equivalent, because it does say at the top, round as a fraction and as a decimal to the nearest 3 decimal places. 0.622, yep. Okay, let's go 3. Who's got 3? Okay, Jack, here we go. Next one, a randomly selected student does not have asthma. So again, we're still not out of 1,000. Does not have asthma. So now we're looking at this row, does not have asthma. What's the probability at least one household member smokes, Jack? There's 301 of them out of not 1,000, but 807. .373. Yep. For this part A? Yeah, that's 73 plus 120. These do, yeah. These add up to 1,000. 193 and 807 add up to 1,000. And so the bottom ones. Okay? All right, here you go. 12. Who's got 12? Okay, here we go. A randomly selected student has at least one household member who smokes. So take a look where we're going now. At least one household member who smokes. So it should be out of 421. Out of those 421, what's the probability a student has asthma? 120 out of 421. And that's 0.285. And I'm not worried about, don't worry about D. We're not worried about interpreting these yet. All right, I want to make sure you guys find the probability. All right, little time on your own now. On your own. I got associates, bachelor's, advanced, male and female. I will do part A with you, and then I'm going to let you go to B and C on your own. Probability, you're male. What's this bar mean again? Given you have, so it's already given you have a bachelor's degree. Already given you have a bachelor's. That's the only one I'm looking at. It's already given. So out of the ones who have a bachelor's degree, how many are going to be male? All right, out of everyone who has a bachelor's degree, what's the probability I get a male? Here you go, 20. How many males are there that have bachelors? Sorry, 20. How many? It's all right. How many males have bachelor's degrees? 547 out of, now if you see a little difference here, I didn't give you a total here. So we got to find the total on our own. Okay? How many out of, how many have bachelors? Yep, and I'll save you guys time. That does not reduce. Okay? So Given they have a bachelor's, what's the probability they'll be male? Go ahead, B and C. On your own in your group, about 1 minute right now. Probability, you'll have an advanced degree given you're female. Probability you're female given you have an advanced degree. Okay. All right, here you go. Probability you have an advanced degree given you're female. Well, I have to look at the female column. Out of all these females here, you're already female. What's the probability you have an advanced degree? So out of all the females here, what's the probability you're going to have an advanced degree? Here we go. What do we got? 7, what do you got for me? What was your first number? 322. Yep. Out of 14? Yep. Again, that's females, because you're already given your female. And that is advanced in female. Flip it on you now. Not the same probability, that your probability you're female in advanced. Why? Because now we're looking at, oh, wrong color. Now we're looking at the advanced. So given you every advanced degree, what's the probability you're female? What do you have for me here? Here we go. 7 again. The troop repping it today. Yep, female and advanced, 322. But now it's out of the number of advanced degrees. Yep, 567. All right. Anything before we go into the last third here? Anything you want to ask me? Reading it off the table. Because now it's, what if you don't have nothing? Other than I give you a couple probabilities, and I still want this conditional probability. Are we okay reading it off a table? We're all good reading it off a table. All right, now, no more tables, no nothing. All I'll provide you with is a couple probabilities. All right. And here's the formula, the one formula here I need you to remember. Probability of B given A, and this goes back, ladies back there, this goes back to what we did at the beginning today. Probability of B given A. The numerator can always be found by finding the intersection of the two. What's the probability that both happen? Denominator is always the probability of the given happening. So A in this case. So the probability of both over the probability of the given. Let's go back to the Brown School. Student takes Math 8 and Technology, 0.12. They still offer technology down at the middle school? It's probably been years since I've been in middle school, so I don't know. Still got tech down there? Okay. All right, we're good. So probability a student takes both of them, Math 8 and Technology, is 0.12. That's a probability. Probability a student takes Math 8, 0.16. Here's what I want to know. Find the probability. Student takes Tech. What do you want to call Tech? T? Good idea. Tech given there's my symbol, given math 8. How about just an 8? Did you say Q? Okay, that relates, yeah. Okay. So how do I find this probability? Use our formula, ready? The numerator is going to be found how? That's the probability that they take both tech and, should start using my symbols, yeah. And math 8. Probability they take both. What should go on the bottom? Probability they take, what did I give you? Given they take math 8, so that should go on your denominator. No table here, but I did give you the values, didn't I? What's the probability? Don't say anything. Let's hear for some voices. 17. Probability, tech and math 8. 0.12. Gave it to you. Nice. You want to keep going? Probability they take math 8. 0.16. There you go. So what about the probability they take tech given they're already in math 8? We're looking at about 3/4, right? 0.75. Again, probability they take both on the bottom, probability of the given one on bottom. Right? Top is probability they take both. All right, last one. We'll get into you guys now. A little senior class action. 2.3% are in the Key Club. 8.6 are enrolled in AP Physics. And what? Okay, anyway. And 1.9 are in both. Determine the probability of P given K. P given K. Nearest tenth of a percent. What's P again? They're in AP Physics. K again means they're in the old Key Club. All right. So we know it's one of these conditional probabilities. Who's got 4? Okay, Austin, ready? The formula says, what should I always put on top? Probability they take. No, don't give me any numbers. Just probability on any conditional probability problem. In the numerator goes the probability they take. And, right? Physics and Key Club. Can you find that percent while we're here? You don't need to calculate anything. Just go ahead and reread the problem because I think I gave it to you. They take both. 1.9. What do you want to do with that 1.9? Anybody want to change it to a decimal? You don't have to, by the way. You can keep it 1.9 as long as it's percent over percent. Yep. What should be going on the bottom now according to the formula? The probability they do what? Here we go. 20. Probability. Numerators always they do both. Denominator is the probability. Perfect. That they're in Key Club. And I give this question, we used to give this question on a test, and everyone would say 8.6. Anybody know why? Because they see it right next to K, and they think, oh, the mind just goes, oh, they go together? Sorry, Matt. Okay, because remember the formula, going back to the formula. Probability of B given A. A was on the bottom. Probability of technology, math 8. What did I put on the bottom? Math 8, right? Whatever is given, that's the probability I put on the bottom. So here it's probability you're in physics, given you're in Key Club. So I gave you're in Key Club, that goes on the bottom, which is 2.3, everyone. What's the probability now to the nearest tenth of a percent? 82 point. What are you guys getting out? Let's not do this for free here. 1.9 divided by 2.3. Okay. 0.82608. We'll just keep it there. Okay, but nearest tenth of a percent. So multiply that by 100. Round, what do we get? 82.6%. That's the probability you will be in AP Physics given you're in Key Club. And then real quickly at the end here, principal wants an interpretation of these results. What are we going to tell them? So of the senior class, what did we just find? Of the senior class, 82.6% of seniors do what? Well, what's this? 82.6% are in AP Physics given they're in Key Club. Yep. Oh boy, PH. There we go. Physics given they're in Key Club. Yes. What's that? No. That's saying that they're already in Key Club. Of those people in Key Club, 82%, like if you guys right here, you're all in Key Club, 82.6% of you are also in physics. I'm not including everybody. It's just the people in Key Club. 82.6% of the people in Key Club are also in physics. Okay? Try some of these out, please. Try some of these out. Remember, starting today after school, come on in. 3 points on the test if you want them.
What's the limit on?
Once a day. 9 max. 9 points max.